the total final mechanical energy. Or you can say that the initial kinetic energy plus the initial potential energy should be equals to the final kinetic energy plus final potential energy. Okay. This law sometimes can also be framed like this. Energy can neither be created nor destroyed. It just changes its form from one form to another. Okay, please write both the things. Whenever done noting down, just tell me.
So finished.
Please remember, whenever we talk about external force acting on it is zero, and whatever internal forces are there, for work energy theorem to be applied, the internal forces which we are having, internal forces should be conservative in nature. What do you mean by conservative? The internal forces of the system should be conservative. For example, do you remember when we took mg as internal force? When we took mg as internal force, then we considered the mg as the potential energy due to mg, right? Yes or no?
Yes, sir.
So there we applied. Always remember, when you will apply work energy theorem only when the internal forces are conservative in nature and there is no external force present. If some of the internal forces of the system are non-conservative, and if they do some work, then this law will become invalid. Okay, then the total mechanical energy won't be constant. Some energy will be dissipated. Always remember this. For example, friction is present. If somewhere friction is present, and if you have considered friction as internal force, then it will automatically become wrong, and if you apply work per energy, then it will be coming wrong only, right? So some energy will get dissipated in form of heat, sound, or light. So the best approach is to not consider them as internal force. Just for example, friction, never consider it as internal. Consider it as external only. Okay. So let's see. Question. There is a block of mass m, and initially this block is at a height h above the ground. Now the question is, when the block is released from rest, what will be the speed with which this block will hit the ground? Find the speed with which the block hits the ground. Considered air resistance to be zero. If the air resistance is zero, is there any external force on the system? Is there any external?
No.
If you consider mg as internal force of the system, then automatically you will consider the potential energy. So consider mg as internal force. So therefore no external force is present now. The only force which is acting on it is mg, right? उसके अलावा तो कोई force है नहीं. So no external force. Whenever no external force, then by the law of conservation of energy, the mechanical energy, law of conservation of mechanical. What is the initial kinetic energy? What is the
So
initial
zero.
kinetic energy? Zero.
So zero.
What is the initial potential energy?
mgh.
And what is the final kinetic energy?
Half mv square.
Plus what is the final potential energy?
Zero.
Are you getting my point? Okay. See, it's similar to work energy theorem. Only what is not there? The work done by external agent is not there. Yes or no? If work done by external agent would have been there, if we would have added one more term. तो बस वही तो नहीं, क्योंकि ये नहीं. Is this clear? So here mgh will be equals to half mv square, m and m will get cancelled, and from here v will be equals to under root of 2gh. ठीक.
Yes, sir.
चलो next question. This angle is 37 degree. There is a block of mass m, and the length of incline is 5 meter. Okay. Now the question is, find the speed at the bottom of the plane if the plane is first part smooth and second part rough with coefficient of friction between block and incline. Mu is equal to 0.25. Okay. So how will you do it, guys? See, simple. I told you, you always do it what? Conservation of energy. So suppose if you want to consider MGH in this case, if you want to consider MGH in this case, then will this height has to be considered? If you assume this as the reference point, the ground as the reference point, then you need to find out the height of the topmost part, right? So can you see a triangle getting formed? This is 37 degrees, this height is h, this height is 5. So I can say this is perpendicular, this is hypotenuse. Sine of 37 degree is equals to h upon 5. And from here, h is equals to 5 into sine 37. Now what's the value of sine 37? What is the value of sine 37, guys? Three by 5. So 3 meters. Please remember, guys, I already told you about the triangle, right? Everyone, I told you about this triangle. This angle is 37 degrees. This angle is 53 degrees. This is 3. This is 5. This is 4. The angle opposite to 37 is basically 3 meters. Well, not 3. It will be in the ratio 3 is to 4 is to 5. Always remember this, है ना? So you found out the height. Now, first case when everything was smooth, there was no external force because friction भी होता तो भी हो जाता. So since there was no external force, you can consider initial kinetic energy 0, initial potential energy m into g into h, which is 3, should be equals to what is the final potential energy? The final potential
Half mv
energy
square.
is 0, and this is half mv square. So when you solve it, you get what?
So mass is cancelled.
Mass will get cancelled. So V will be under root of
6g.
twice into G into 3. Under root of 6G. And that's the answer. Okay. Next case, when it is rough. When it will be rough, then will you be able to apply law of conservation of energy?
So can't we just take g's value as 10?
You
and
can
that'll be
take it.
16 to 16.
No problem.
4.
You can take. But unless it's not mentioned, take it at 9.8. When they have specifically mentioned ki take GS10, then only take GS10. Otherwise 9.8. Or you can, if option based questions will come, then you can see the options. If the options are whole number, like 10, 5, something like this, then automatically you'll get the idea कि हाँ 10 लेना है. Okay. So next part. And next part is just like work energy theorem. Please do it. So next part I am leaving as a homework for you people. So shall. So I told you that work energy theorem is nothing but just the law of conservation of mechanical energy is nothing but just work done by external agent 0. So there will be some cases where you won't find any external agent. Every internal force will be conservative. Then automatically your mind should go towards the law of conservation of mechanical energy. Chal. Now the last part of this chapter. What is the last part of this chapter? It's basically power. So please give a heading: mechanical power. Mechanical power is different, electrical power is different. Today we'll be done with this chapter. We'll start with the next one. First of all, we'll give you some questions as well. And tell me, what do you mean by power? Everyone must be knowing the definition of power.
The ability to do work.
The ability to do work is energy. The rate of consumption of that energy is basically power. The rate of consumption of energy, consumption or production, is called as power. Or sometimes, people can also say the rate of doing or the rate of doing work is called as power. And which rate are we talking about? We are talking about the time rate. Basically, we will be dividing it by time. Power is nothing but the work done by the time taken, or you can say the change in energy by the time taken. SI unit of power release, joules per second, or basically what? Okay, right till here. Then we'll talk about the two different power. Acha, हाँ. The power associated with the force. Since we are talking about mechanical power, then always some force will be associated, right? So the power associated with a force can be positive or negative or zero. Whenever it is positive power, that implies the force is supplying energy. And whenever it is negative power, that implies the force is consuming certain energy. Achha, tell me this particular thing. If a force is supplying energy and that force is external, okay, suppose you are there and there is an external force, and if that external force is supplying certain energy to you, will your energy increase or decrease?
So increase.
Increase, because suppose you are the system and someone is giving you certain money. So will your money in the pocket, will it increase or decrease? It will increase,
Increase,
right?
sir.
And similarly, if someone is taking money from you, then automatically your money decreases, right?
Yes, sir.
So remember this. Okay? Done? Whenever you're done writing till here, just tell me. Always remember, power is basically a measure of how fast or how slow uh, force can do the work. Okay? So you can write power, physical significance I'm talking, Power is a measure of how fast or how slow force can do the work. So basically, now we wanted, we included the distance factor in the case of force, or in the case of work. We wanted to include the time factor as well. So we included the time by, introducing a new physical quantity which is called as power. Okay. Now, for a process, we can define power in two ways. कुछ भी process हो रही होगी, then we can define power in two ways. The first way is average power, and the second way is instantaneous power. We'll study them one by one. Shall we start, guys?
Yes, sir.
So let's discuss about the first kind of power, which is basically the average power. Always remember, whenever we use the term average, then we talk about an interval, and that interval is big. Okay. So whenever someone talks to you about average power, this is, by the way, denoted as this as well. In the what kind of brackets do we call them? The conical brackets. This is equals to work done divided by the time interval. And can you see, this is basically what? T2 minus T1 time instants. In case of time instants, we want to say. Okay. So suppose if I have an object on which a force is being applied, so let's say at t equals to t1, it is over here, and at t equals to t2, it reaches over here. Then the time interval in this from here to here, from here to here. Can anyone tell me what is the time interval? Will it be t2 minus t1? So that is it. So that is how we define the average power by work done by time. Okay.
Yes, sir.
Power is not that much, difficult to understand. Power is easy. Same definition. 9th grade also you might have given the same definition. Right? And we know what is the work done by that particular thing, right? We know how to calculate work. Shall I give you one question based on this, or shall I teach you instantaneous power first?
It's a question.
Question. Everyone remembers projectile a little bit, right? Projectile motion. Yes or no? Everyone remembers the projectile motion, right? So suppose there is an object which is thrown with a velocity u at an angle theta. Now when it is thrown like this, it will go like this and reach over here. Yes or no? So suppose
Yes,
there is
sir.
this mass m projectile, it is thrown with a velocity u at an angle theta. Question is, find the average power of gravity in motion. let's say A. Find the average power of gravity from point O to point A. Okay, from O to A, you need to tell me. Find the average power of the gravity. And where is point A? A is the point at a maximum height, H. Na?
Yes, sir.
And we know the formula for average power. It is work done divided by. So work done divided by time taken. So basically, you need to solve two things. One is from here to here, the work. What is the work, and what is the time? So time, we know. What is the time of flight, by the way? The time of flight of a projectile. Tanya,
Yes, sir.
what is the time of flight of a projectile?
Mm, so I don't know.
Parinita, what is it?
I don't remember.
अरे तो रिवाइज करो ना यार. अमन, Cyril, anyone? Yes, Arnav, you know the this thing, time of flight.
No, sir.
Projectile had three
What
major
is that?
formulas. What?
What is that?
Time of flight.
Yeah, what is it? Oh, never mind.
The time of flight was this. The maximum height was u square sine square theta by 2g. Then the range was given by u square sine 2 theta by g. You remember this? These are the major formulas at least. Remember the major ones. So here, what is the force? The force is mg. What is mg is acting downward direction, right? And can you see that displacement is in the upward direction, right? So the work done by gravity is negative. So minus of mg into h shall be equal to or divided by time कितना हो जाएगा? Since 2u sin theta is the time from here to here, the complete time of flight. So till reaching the maximum point, it will be just half of this, the time of ascent. It will be u sin theta by. Now I can solve it. It will be minus of mg into u square sine square theta by 2g divided by u sine theta by g, and g will get cancelled. 1 sine theta and 1 sine theta will be removed. U and u will get cancelled. So what is the only thing which is remaining? This half will be remaining. The negative sign with half mgu sine theta, and that's the answer to your question. Is this clear?
Yes, sir.
Now the second power is basically instantaneous power. This power is not calculated over an interval of time. Just for example, average power was calculated over an interval of time, right? Yes or no?
Yes, sir.
Here, this power is not calculated over an interval of time. You can write this point for average power. Power is calculated over an interval of time. Average power is calculated over an interval of time. Instantaneous power is the power at a given time instant. Suppose करो in a process कुछ भी process हो रही होगी, if you, whether that process of it is shifting an object, pulling an object, pushing an object, whatever it is, in a process of doing work, if for a very small time, how do you denote this small time? We denote it by using the term dt. Dt is basically differential time. Differential time means very small time. Okay. Ouch. That's just 2 minutes. I got a cramp. Basic. So for a very small time dt, if the work done is dw. What do you mean by dw? Differential work, a very small work in a very small time. Okay. Then for this very small interval, we can assume the power is constant, and that power is called as instantaneous power. Okay, guys. So basically, this power, instantaneous power, is that small work by that small time. So suppose karo guys, if I have this object and let's say I am applying a force F. So when this object is over here, I want to displace this object by a very small distance. Can you see the picture at 3 different positions? Can you see this very small distance dx? Although I could have made it much closer, but you won't be able to differentiate it. So I displace it by very small distance dx by applying a force F, right? So can I write the work is basically what dw will be equals to the F vector dot dx vector, right? So dw will be this. I can write the expression for instantaneous power as well. F dot dx by dt. And now what is dx by dt, guys? What is dx by dt? The rate of change of position.
So velocity.
The velocity, the F dot v. So please remember, whenever someone asks you what is the instantaneous power, then your answer will be what? The dot product of the force vector with the velocity vector. Either you can write it like this, or is equals to Fv cos theta. So what is theta over here? The angle between force and velocity. Please remember, a force will be in the direction of the velocity vector. Then if the force is supportive in nature, then the power will be positive. If the force is opposite, then the power will be negative. All depends on this theta. Okay. Chalo.
So finished.
The same case again. There is an object of mass m with a velocity u is thrown at an angle theta. It goes like this. Yes or no? At a time t equals to t. Let's say I have thrown it at t equals to 0 and it reaches over here at t equals to t. When it reaches over here, the velocity vector will look like this. Yes? Yes or no? So the question is, a body of mass m is thrown at an angle theta with the horizontal with initial velocity u. Find its instantaneous power developed by gravity as a function of time t. Basically, you want this. How will you do this? So basically, this is your velocity vector, and what is the force? Force vector is this. Again, you will need the basics of projectile motion again. So, किसी को याद हो तो फिर करो. I'm giving you 2 minutes to solve. You can check your notebooks. What is the velocity vector? We know the instantaneous power is basically can be calculated by the dot product of force and velocity. See your older notes where you have projectile motion. And what is the velocity vector? Try to find out. What is the mg vector? Try to find out and then do it. Guys, was this the velocity vector at any instant? And what is the force vector? Minus of mg j cap. If I assume this as positive, this as positive, so this will be negative, and this will be also negative. So minus of mg j cap. Now you have your force vector, you have your velocity vector. I think you can multiply them now.
Yes,
Enough?
sir.
You can calculate the dot product. Chalo, calculate.
So what's the final answer? Is it u cos theta I cap plus mg square t minus mg u sine theta
There
j
won't
cap?
be any term for u cos theta I cap, because when you'll do the dot product, can you see there is no I component over here in the force, and I
Yes,
dot
yeah.
zero हो जाएगा नहीं, only j
Zero,
dot j
yes,
will be.
yes. Yep,
So
yep.
the instantaneous power will be only this j component multiplied with j component. So minus of mg multiplied by u sine theta minus gt. And when you calculate this, it will come minus minus plus mg square t
Square t
minus
minus mg u sine theta j cap.
nah, j cap is gone, j dot j is gone, j dot j is 1 if you remember.
Yes, sir.
So I think it is that. That's the answer. And can you see the power, instantaneous power as a function of time? Done, guys?
Yes or no?
The question. A man lifts 100 stones to a height h equals to 6 meter in 2 minutes. If mass of each stone is 1 kg, then what is the average power? How will you calculate this, guys? Simple, work done nikalo and just divide it by time, right? See, basically work is done what we are lifting it to a height of 6 meter, right? So basically we are increasing the potential energy. So can I say this the thing work done will be basically what? The gain in potential energy of the stones, right? So that will be equals to how many stones are there? 100 stones are there. And the energy increased of one stone is how much? 1 kg multiplied by m into g into h.
Height 6.
So will this be equals to 6,000
6,000 joules.
joules? And now this 6,000 joules is in how much time?
2 minutes. So 6,000 divided by 2 into 60.
Simple question. हाँ तो बड़ा.
Yes, sir.
So this will be 50. चलो next. With coefficient of friction, okay, and then constant horizontal force is applied on it so that it starts accelerating with acceleration A. Now the question is find the power of the applied force at a time. So basically there is a block on which you are applying certain external force. There is this friction and this block shall accelerate with an acceleration A. Okay. The coefficient of friction is mu. So you need to find out what is the power applied by this force. First of all, guys, you need to find out what is the force which shall be applied to provide an acceleration A. Here the force is not given to you, right? So basically the force which you will apply, can you write the force equation from here? F minus small f is basically equals to mass into acceleration, right? So from here, can
Yes,
I
sir.
say F, capital F is basically ma plus small f. So ma plus mu into m into g. This is the force. Once we have find out the force, then we can find the power as well. So the instantaneous, can you see this is going with a constant acceleration. So this is equals to F into V into cos theta. Theta is 0 over here because force and velocity is in the same direction. And can you say initially it was at rest, acceleration is constant, and after a time t, we are asking. So we know this particular thing, V is equals to U plus AT. So 0 plus A into T is basically V. So F will be MA plus mu mg multiplied by 80, and that's the final answer. Okay, easy. Is it easy, guys?
Yes, sir.
There is one relation between average power and instantaneous power. So you can write this relation in case. Relation between average power and instantaneous power. Once you're done with solving, once you're done with noting down the previous numerical, just tell me. We'll write the relation. Done, guys. कोई बोलता ही नहीं आजकल. The average power is basically given by 1 by T2 minus T1, T1 to T2, instantaneous Tt. Not only power, this is relation between any physical quantity. If you want to give a relation between the average and the instantaneous parts, then always remember this will be the relation, and just replace power by that particular thing. If suppose someone gives you a relation between, what is the relationship between average velocity and instantaneous velocity, then in just place of this power you'll write what? V, right?
Yes, sir.
Chal. I'll give you 2 questions as homework. This is 1 question I can give, and 1 question will solve this. Based on this, we'll solve it. 1 question I'm giving homework, which can be solved by normal methods. An elevator of mass capital M with a person of mass small m inside is moving upwards with a velocity v. Okay. Now, what is the power delivered by the elevator? What is the power delivered by the elevator? This is a homework question, one liner only. Next question. A small body of mass m is located on a horizontal plane at a point now the body acquires horizontal velocity v naught. Now the question is, find the mean power developed by the frictional force during the whole time of motion. Suppose मतलब basically यह है कि when the object is over here, it is moving with the velocity v naught. Okay, and it keeps on going. So basically, what will happen? Friction will act. There is no external force, so due to which what will happen? Its velocity will decrease. Okay, v will be less than v naught. Due to this frictional force, the velocity will decrease. ये लॉजिक से थोड़ा सॉल्व करने की कोशिश करो. चलिए. And during the whole time of the motion till it stops, right? अपने को जब तक वो रुक नहीं जाता तब तक क्या करना है? Till it stops. चलो, try to do it and give me 2 minutes. I'll be just back from washroom.
So no idea.
No idea. So let's say at t equals to 0, this is over here. At t equals to t, the velocity becomes this. Now tell me what force is acting. The frictional force is acting. The force is equals to mu into m into g. Yes or no? Shall I draw the free
Yes,
body
sir.
diagram? It's fine. N upwards, mg downwards, and friction in this direction, which is equals to mu multiplied by n, which is mu m. The frictional force is this. Now this frictional force is causing a deceleration in the object. So what is the deceleration? Will it be equals to mu mg divided by mass? Can you see the deceleration is mu g, right?
Yes, sir.
After this, we know v is equals to u plus at. So v is equals to u plus at करने के बाद क्या होगा? Initial velocity is v naught. Acceleration is minus mu g into t. That is the final velocity at any general time, right? Now you got the instantaneous velocity, you got the force. So I think you can calculate the instantaneous power, right? So the instantaneous power will be equals to what? The force. What is the force? Mu mg.
Time velocity.
What is the velocity? V naught into mu minus mu g. And what is the angle? Cos
180.
180.
Minus 1.
So will this be the instantaneous power? I say there is no need for this because we want to calculate what is the instantaneous power, right? So sign not necessary as of now. Even if you don't write, we just know that this will do a negative work. The friction is doing a negative work, so automatically that sign is in our head. Okay.
Yes, sir.
So just the magnitude of instantaneous power developed by friction is basically this much. And now what will you do? You'll calculate the average power. Average power का relation, 0 to t and 0 to t, t1 to t2, p instantaneous dot dt. Achha, can you tell me what will be the time till which it will stop?
So t.
T will be the time, but can you tell me what will be the time in terms of all these things? If I say the final velocity is 0, initial velocity is v naught minus mu g, and let's say the time is how much? Capital T, where it is stopping. Okay. So, despite of doing it over here, let me do it over here. If T is the time when it stops, then v is equals to u plus at. V is basically final velocity 0, initial velocity v naught, acceleration is minus mu g, and time is t. So from here I can calculate the value of t as well. V naught divided by mu g, right? Now I can put this in this formula. So the average power from starting till end is given by 1 by the second instant is 0, 0 to t, and instantaneous power was what? What was the instantaneous power? What was the instantaneous power?
V naught umg into v naught minus ugt mu gt
into dt, right?
Yes.
So now you just need to do integration. So 1 upon t mu mg is a constant thing, it will come out, and you need to integrate only this function, which will be v naught minus mu gt to dt. So what is the integration of dt? Can you see this is a constant, it will come out. V naught integration of dt will be v naught into t minus mu g t dt. t dt का integration होता है t square by 2. Yes or no? And then you will put the limits from 0 to t. So this will be equals to mu mg by t And when I'll put the limits, the upper limit minus the lower limit put करूँगा तो everything will become 0. Upper limit put करूँगा तो v naught into capital T minus mu g t square by 2. And I think now it's solvable. 1 t will get cancelled out. So mu mg into v naught minus mu into g into t by 2. What was t? V naught by mu g. 1 by 2. Mu g से mu g cancel. V naught minus V naught by 2. So final answer is mu mg V naught का half. And we know this power is negative, right? Yes or no, guys?
Yes, sir.
So
Was
that's it.
stop.
That's the answer to this question. Clear?
So are these the kind of question that come in school exam as well?
Never.
Oh, okay.
These are the type of questions which will come in your advanced, J advanced. So whenever you're done, just tell me to scroll up or down.
So could you just scroll up?
More up.
Yes, sir. To the where you made the yeah, sir. Yeah.
From the beginning. Okay.
Yes.
There is one last thing which is basically called as efficiency. Small topic. Only that small topic is left, and the rest everything is done.
So done.
Done the whole thing. Okay, done with that part.
So that part.
Okay. Chalo, लिखो सब लिखो. See, the steps are very important. What I told you, okay, what we wanted the average power, but there was no, we couldn't find out the average power because we didn't know the instantaneous power. So, पहले instantaneous power we calculated, then we averaged it out. Okay.
So done. So finished. I finished the rest of it.
So last question, what do we call it? Topic is something called as efficiency. What do you mean by the efficiency? Efficiency is basically the ratio of the output power to the input power. Or basically you can say how much power is used divided by the total power given, the total power supplied, right? So denoted by eta, and this is P output divided by P input. Basically what will this ratio tell you? This ratio will tell you how much power is being utilized actually out of how much you have supplied. So suppose karo ki if I say there is an engine which is 80% efficient, है ना? So basically if that engine is supplied how much power? Suppose this is the engine and I'm supplying let's say 200 watt of power to this engine. So basically how much work this engine can do?
160.
160 watts. So that is what is meant by efficiency. And this thing is basically your input power and this thing is basically your output power. So can you see 160 divided by 200 is basically what, 80%, or you can write as 0.8. Please remember this eta will come in fractions. Okay, it always lies between 0 and 1. It can be equal to 0, it can be equal to 1, right? If you want to write eta in case of percentage, then it will be P out divided by Pn multiplied by 100%. You can write it like this as well. Okay, it will be much more clear if I give you one question based on it. Okay, it's fine. You understood with this example.
So one question would be fine.
Question. A water pump rated 400 watts. What do you mean by rated 400 watts?
So max power it can give is 400 watts.
Yes. Or we can say the maximum power which you can give as input is basically how much? 400 watts. It has an efficiency of 75%. If it is employed to, देख तो किसी को पकड़ा गया? कुणाल? To raise water through a height of 40 meters. Find the volume of water drawn in a minute. Okay. So first thing, if it is 75% efficient, matlab kya? Sir, you are giving it how much? 400 watt. But how much will be the output? Will it be equals to
So
eta?
300 watts.
Exactly. It will be eta multiplied by input power. This will be equals to 75% of 400 will be 300 watts. Yes or no? So basically how much power you are, this is able to produce 300 watt. That 100 watt, additional 100 watt is lost somewhere, right? Now we know
Yes,
the
sir.
power is basically what? The work done by
Time.
time. So it will it be equals to D if I say I am raising water to a height of 40 meters, that implies I am increasing its potential energy. The work done is basically the increase in the potential energy of water divided by time. Yes or no? Yes or no? It will be much more better if you use it in the differential form. So see, power, if it is equals to dw by dt, instantaneous power is this much, right? So can I write it as d by dt of mg into h? Now g and h is constant, it will come out. Yes or no? Can g and h come out? So this will be dm by dt. And what is this dm by dt? The rate of mass raised to a height h. Can you see the rate of mass? The mass divided by time. Okay. So this will be equals to p. So from here I can say dm by dt is equals to p upon gh, and the power you will use over here will not be 400, it will be 300 divided by 10 into 40. So this will be equals to 0.75 kg per second. Now this much water is being drawn every second. So in time, how much time? In 10 minutes, the mass of water drawn will be equals to how much?
0.75 into 600.
0.75 into 600, which is equals to how much?
So
3 by 4, no?
470.
450 kg. This is the mass of
Yes.
water. But did they ask mass? Did they ask mass?
No, so volume of water.
They asked volume. So how will you convert volume from mass? We know this particular thing, density is equals to mass upon volume. So volume will be equals to mass upon density. The mass is 450 kg. And what is the density of water?
1.5.
The density of water is 1000 kg per meter cube. 1 gram per centimeter cube or 1000 kg per meter cube. Okay. So from
Yes,
here,
sir.
the volume will be 0.45. That's the answer. Not so difficult, I guess. So with this thing, I'm done with your work, power, energy. Complete chapter is done. In the next class, I'll be starting with a new chapter, which is named as conservation of, no, not conservation. What do we call it?
Mass.
Conservation of momentum. No, not mass. Conservation of momentum chapter, system of particles, center of mass, all these things will come. So anyways, is this thing clear, guys?
Yes, sir.
Chaliye.